Alright, so welcome to our first set of notes in Unit 2. So Unit 2 is all about triangles. And there's two different types of triangle relationships. So when you have two triangles, I guess there's three because they can be completely different, or they can be similar triangles, or they can be congruent triangles, meaning they'd be the exact same. So our first lesson is we're going to talk about congruent triangles. So the name of the notes is Conditions for Triangle Congruence. So before we begin, we have to define a few things. For example, two triangles are congruent, meaning the exact same, if, so two triangles that have all three angles the same, and all three sides the same, in the same order. Okay, so for two triangles to be the exact same, all three sides have to match and all three angles have to match as well. And so if two triangles are the same, we say they're the same by writing something called a congruency statement. So a congruency statement is how we say that two triangles are the same. So what it is it's how we say two triangles are the same. However, triangle or congruency statements have a couple rules. For example, so here are some rules. Okay. The first rule is that this symbol right here, an equal sign with a little tilde above it, that's technically how you say congruent. So this symbol means congruent. The reason why it's not just an equal sign is because an equal sign is saying that it is that. And this triangle isn't this one. It just happens to be the exact same in measurement. So they're two different triangles, so I can't say equals each other because they're not equal. They're not the same thing. However, they share all of the same characteristics. So they're congruent because they're the same in every way. They're just separate of each other. So for congruence, we put an equal sign with a little tilde mark over it. In the last unit, every time we did congruent, we didn't use this symbol. But from here on out, we need to use this symbol to say that two things are congruent to each other. The other rule for a congruency statement is that the order in which you list the letters matters. So the order you list the letters must match the other triangle. So the order matters because you have to make sure they match. When we get to the end down here and do a congruency statement, I'll explain that much better. Okay, so at the moment we have two triangles in our example. We have this first triangle, triangle TRI, and the second triangle, triangle AGN. And I'm telling you right now that they're the same, they're congruent triangles. However, we can't see that yet, because right now, well, they both have 90 degrees, and they both have a 60 degree, but we don't know their third angle. And for the three sides, this one has a 3, and this one has a 3. But this one has a 4, and this one has a 5. And we don't know about their third side. So we don't know yet for sure that they're the same, because they didn't give us all three angles and all three sides. So if they don't give us all the information, we have to figure it out. So remember, so how to determine a missing angle? In any triangle, all three angles must add to 180. So all three angles must add to 180 degrees. Okay? So I'm going to call this first triangle triangle number 1. right? So for triangle number 1, 60, which is this guy, plus this angle here, which is 90 because of that little box, needs to equal plus this third guy here, whatever it is, let's call it x. It needs to equal 130. 180. So 60 plus 90 is 150, plus something is 180. So the answer is that x is 30, because 150 plus 30 is 180. So this angle here is 30. And for triangle number 2, we can do the same thing. So let's call this one number 2. And I'm going to put a little x in the angle we don't know. And again, my other two angles are 60 plus 90 plus the x we don't know is 180. So when we add, we get 150 plus x equals 180. So x has to be 30 in order for it to add to 180, which means this angle right here is also 30. So now I have all three angles being the same, a 60, a 90, and a 30. But in order for them to be congruent, I also have to know all the sides are the same, and I don't know that right now. So in order to determine a missing side, and it's important, I capitalize, when it's a right triangle only. So this only works if there's a right angle, a 90-degree angle in the triangle. And here is what it's called. It's a method called Pythagorean's theorem. Hopefully you learned Pythagorean's theorem before this lesson. And if you haven't, let me know and I can give you a lot more practice on it. However, this is quickly what Pythagorean's theorem is for a right triangle. So Pythagorean's theorem says this. For a right triangle, because it has to be a right triangle only, for a right triangle, a squared plus b squared equals c squared. Now, let me explain what that means. When you have a right triangle, so it's a right triangle because there's a little box with 90 degrees. The side across from the 90 degrees, so if I go straight across like that, this is C. It's called your hypotenuse. So C is always the hypotenuse. And the hypotenuse is always across from the 90 degrees. And that's really important, because it equals c squared always. Now A and B, it doesn't matter which one it is between the other two. You can just choose. So I'll let this one be A and this one be B. So in my picture up here in triangle number 1, I'm going to let the 3 be A and the 4 be B, because C is the thing we don't know, the hypotenuse. We don't know this length right here. Well, if I follow the formula, so for triangle number 1, if I follow my formula, it says A squared, well I just made A3 squared, plus B squared, and B's 4, so B, which is 4 squared, needs to equal C squared. And C is the one we don't know, so I'm going to just leave it as a C. Well, 3 squared means 3 times 3, so 3 squared is 9. Plus 4 squared means 4 times 4, and that's 16, equals C squared. And we don't know what C is. Now 9 plus 16 is 25. So 25 equals C squared. Which means whatever C is times itself is going to be 25. And the answer here is that it's 5, because 5 times 5 is 25. So the answer is that C is 5. So up here, this guy is 5. Okay? Then if I do it for triangle number 2, well, the hypotenuse is across from 90 degrees. So this is C. It doesn't matter which one we make A. This time I made it 3, so let's make it 3 again. Why not? And then the missing side, the one we don't know this time, is B. So I use the formula A squared. So A was 3 and number 2. So 3 squared plus B squared. I don't know what B is, so I'm just going to write B squared. Equals C squared. And I know C is 5. So it's 5 squared. When I work it out, 3 squared is 9. I don't know B squared at all. because I don't know what b is. And 5 squared is 25. So when I go to solve, I minus my 9, minus my 9, so that b squared equals 16. So there's some number out there, when I times it by itself, because that's what squared means, is 16, and the answer is 4. B is 4, because 4 times 4 is 16. So then up here I can say b is 4. So now if I look, are my two triangles congruent? Do they have all three sides the same? 5, 5, 4, 4, 3, 3. And then, do I have all three angles the same? 90, 90, 30, 30, 60, 60. I do. These two triangles are the exact same. Or at least they're congruent. So, to write a congruency statement on them, here's how it works. You always put the triangle symbol first to let them know you're talking about a triangle. So, triangle. And I'm just going to pick any letter in any order. I'm going to start at T, and then go down to I, and then go down to R. So, it's triangle T, I, R. The order you make this first triangle doesn't matter. I could have gone in any order. I could have gone RTI, I could have gone RIT, I could have gone IRT. It doesn't matter as long as I start at one and move around the circle somehow, or I move around the triangle. However, this second one matters a lot because we're going to say it's congruent, so the equal sign with the little tilde mark over it, like that. It's congruent to triangle. And it matters. It really, really matters that you go in the exact same order. So we started with the T. The T was the 30 degrees. So when I look over here, the 30 degrees is the G. And I need to make sure if I'm listing T first, then the second time I have to list the G first. G. Then I move along this side, which is 5, and go to I. So then from G, I move along the side that's 5, and go to the next letter, which is N. And if you look, both I and N are your two 60 degrees. Then from there, I move along the side that's 4, and get to R. So from my N, I move along the side that's 4, and get to the A. And you can also see that angle A is the 90, just like angle R is the 90 over here. So it's important in the congruency statement that the order you list your letters must match the other triangle. Like they must be aligned. Okay, go ahead and flip the page over. So here's the thing. I just told you that it's really, really important for two triangles to be congruent, that all the sides have to be the same and all the angles have to be the same. However, you don't always need all that information. And here's why. There are 5 conditions of triangle congruence that if you have these things, it forces the triangles to be similar. It forces them to have all the same angles and same sides. Like, it's impossible to make a different triangle that isn't congruent to the triangle when these 3 things are always the same. So here's the first one. If two triangles have all 3 sides the same, side, so the S stands for side, side, side. Side, side, side. So as long as they're always the same around the sides, it's going to force the angles to always be the same. And it happens all the time. I can prove it to you. There's a cool little toy we could play with. What I found is most students don't care that it's true. The fact is that it's true. And so just know that as long as you have all 3 sides the same, you're allowed to say they're congruent. Here's the important part though. They have to go in order. So if you look at tick mark 1 here, let's say it's a 3. That means tick mark 1 here is a 3. Right? And then, so if I go to this dot to this dot to get my 3, that's a length of 3. For my one with 2 tick marks, this one, if it's a 4, that means the one with 2 tick marks over here needs to be a 4 too. It's not okay for this one to be the 4. And then the next one, if it's 5, the one with 3 has to be 5 as well. So it has to go in the same order. But as long as all 3 sides are the same, then the 2 triangles are automatically congruent. It's also true if there's a side that's the same, followed by an angle, and then another side. So again, it's important that it goes first this side, then the angle right next to it, right, like attached to that side. This angle, and then the next side, is the same on another triangle, where there's a side, and then an angle, and then a side. That will end up being the exact same. And this one, it's important that the angles in between the two sides that are the same. The next one, ASA, stands for an angle, then a side, then an angle. So if you look, they both have one angle, and then it touches a side that shares another angle that ends up being the exact same on both triangles. Then AAS stands for angle, side. So if you look in this picture, it had an angle, and then another angle touching a side that has a tick mark. And it's the same angle over here. These two are the same. The second angle is the same, and they both have the second angle touching the side. That's the same. Because it needs to go the angle, then the side, being all congruent. And then finally, there's hypotenuse leg. So HL stands for the hypotenuse and a leg. Because as long as the hypotenuse, being the one across from 90, is the same, and one of the legs is the same, because of the Pythagorean theorem, the other two legs are going to be the exact same anyways, so you don't even need all three of them. It's enough if you just have two when it's a right triangle. So this only works for right triangles. So only for right triangles. Okay. So I'm going to jump up to ASA and quickly show you one of these that doesn't work. Let's say I have a triangle like this, and I have another triangle like this. Okay? And let's say this angle's 10 and this angle's 10. So these are the two matching right now. Okay? And then this side becomes 5. And then my next angle, so I'm at this angle, then I hit that side, I'm at this angle, and then I hit that side. And then I'm going to come to this angle and say it's 50. Well, this time, in order for them to be the same, if this is 10, following the line down, this one has to be 5, and then this one over here has to be 50. So let's make this one 50, but let's say it's this one that's 5. These two are not congruent anymore. It doesn't work. Even though they have two angles and a side, it's not going in order. It needs to go the angle, then the side, then the angle. Like if I put my pen on it, I could draw this angle, continue along the side, and draw this angle without ever lifting it up. But over here, I draw this angle, and then to get to this angle, I'd have to pick up my pen and skip down here, because the 5 isn't the one in between them, and it should be if they were the same. So these two are not. These two are bad. It's a bad example. Okay? They're not congruent, but these two are because of the way they match, where they have an angle, and then the side, and then the angle. So the order you hit things in as you go around the triangle matters.